Oh,
Yeah.
thank you very much. Thank you. All right. So we're gonna start. I'm your host for this talk. My name is Andrii Shcherba. I lived in Ukraine for many years, and I was the regional back in the day organizer of Rust Ukraine. And right now I work at Ferro Systems, a company that also focuses on Rust a lot. And in particular, we're also interested in Rust for automotive industry. We are building a version of qualified compiler called Ferrocene, which we target for automotive industry. Yeah. And I don't work on Ferrocene. I work on Rust Analyzer, among other things, and mostly doing Rust trainings and also some customer projects. But we are big believers in Rust and big believers in Rust in safety critical applications like in automotive. So today we have two incredible people with us, Andrii and Serhii. Serhii is a principal C++ engineer at the company Intellias, and he's been doing C++ for 15 years and more, which is super impressive, to be honest. And he's also interested in Rust, like many C++ programmers out there. And he's working really hard to make C++ safer and also to use Rust to improve safety of critical systems even more. And along with Serhii, we have Andrii Shcherba, who is a C++ architect at Intellias with 10 years of C++ experience, but importantly, 5 of those 10 years are related to automotive industry, which is super cool. Andrii has been working really hard to make our cars more safe, better to drive, more secure, and also easier to just use and more comfortable, which is super admirable because cars are scary. They're big, they're made of iron, and they can kill people, but they also do a lot of amazing things like moving stuff around. So anyway, they will talk to us about use of Rust in automotive industry, in particular in AUTOSAR, which in itself is a very big consortium of companies. I think BMW, Toyota, Mercedes, I don't remember other car brands, but there are like 300 plus companies that participate in this big initiative. And together they're building a set of programming standards, guidelines, etc., about how certain things in our cars, software-wise, has to work. So it's a very important work that they do, and they'll talk more about it. So the stage is yours.
Great, thank you. Hi all, happy to see you on Ukrainian Rust conference. Today we're gonna discuss benefits of Rust usage in automotive. Serhii, can you bring next slide? Yeah, great. Rust enabled AUTOSAR. We will discuss benefits of Rust usage in automotive, huge opportunities which automotive domain can bring to Rust developers, and great perspectives for Rust to become part of automotive in nearest future. Here you can see short content of our today's presentation and your speakers, me, Andrii Shcherba, Serhii Ternovtsov, and also we should have special guest on Q&A session, Christoph Petik. Let's start from overview of AUTOSAR and automotive domain itself. Automotive is really huge. There are a lot of different directions of development. You can see here many of them, but of course not all of them, because automotive is much more bigger. On this diagram, you can see how fast automotive is growing, especially last year. So you can see how fast number of ECUs is growing inside of the car. One note that ECU is electric control unit, and basically it's functional node inside of the car, so we can make straight line between number of ECUs and number of functionality inside of the car. This growth is based on growth of features which we have inside of the car. You can see that last 10 years we got a lot of new trends and directions inside of automotive, like electric cars, connected cars, autonomous driving systems, and especially very important is software-defined vehicle concept, which is basically game changer on the market, because now we are looking at car not like on the vehicle which can bring us from point A to point B. Now we are looking at car like on a big smartphone with wheels. Next slide, please. If we are talking about automotive, no chance to not talk about AUTOSAR a bit. So AUTOSAR is a very big consortium inside of automotive, which was founded 20 years ago in 2003. And today it has more than 350 partners. And Intellias, by the way, also part of automotive consortium. Next slide, please. Currently, Automotive has two platforms. On the left side, you can see AUTOSAR Classic platform. It is well-known technology on the market. It is based on C and has monolithic architecture. AUTOSAR Classic was optimized for low latency operations and high ASIL levels. ASIL is functional safety level. We'll talk about it a bit later. And on the right side, you can see AUTOSAR Adaptive Platform. It's new platform. It was not created to substitute classic one. It's created to be an addition to classic platform and meet new challenges which we have in automotive. AUTOSAR Adaptive, already based on C++14, has service-oriented architecture and optimized for flexibility and high-performance operations. Next slide. For our presentation, important to talk a bit more about communication stack in AUTOSAR Adaptive. Since we have service-oriented architectures there, we using a proxy skeleton pattern for communication between different services. In general, you need to make service interface definition using RXML format. It's special XML-like format for AUTOSAR. And from this service interface definition, we will generate proxy, skeleton interfaces, and middleware transport layer. Using all of it, we can establish communication between different services. Next slide, please. As I promised, we will talk also about ASIL levels and functional safety. So ISO 26262 is functional safety standard in automotive, and it is very important standard for automotive because automotive really cares a lot about safety. Inside of this standard, there were defined 4 ASIL levels. ASIL, as you can see, it's automotive safety integrity level, and we have for levels from lowest A to highest D. We can view on examples like both rear lights failure is ASIL A because it can lead to some harm, but maybe to not big injuries. And on opposite side, self-steering is ASIL D because any failure here can lead us to very big injuries. Next slide. Also would like to talk more about projects of Rust integration in automotive. Here you can see a timeline of main milestones of Rust integration in automotive. In middle of 2019, we got first articles about Rust in automotive, and in September 2020, we already got very good presentation by Feroz Systems about the benefits of Rust usage for functional safety development and automotive also. In February 2021, Ferrocene compiler was announced, and it is very important for automotive because this compiler should be compliant with ISO 26262. In March 2022, 2 working groups were created. One was created in SAE, it's Society of Automotive Engineers, also very big organization inside of automotive, and another one was created in AUTOSAR. And me and Serhii and Christoph Petik, we are part of this working group in AUTOSAR. Christoph is lead of this group. In October 2022, Romanian startup AUTOSAR raised funds more than 1 million, and it is important for us because this OS is written in Rust, and recently OxidOS joined AUTOSAR as well, so we have chance that this OS will be used in automotive in future. And from current activities, which we see that some R project is under development, it's Rust implementation of some IP protocol. It's important because some IP is used for communication in AUTOSAR Adaptive. And also recently we got full support of QNX Neutrino standard library, which is a very, very popular operating system in automotive. Next slide, please. On this slide, you can see several more projects with Rust in automotive, just to show you that there are much more projects with Rust and automotive, but we cannot go through all of them because of time limits of this presentation. Next slide, please. From all of it, we can see several major trends. One is that C++ does not hold monopoly in automotive world anymore, and at the same time we see that Rust is looking for new areas, new domains for expansion, and automotive is very good candidate for it. And also we see that car makers and tier 1 suppliers are already preparing ground for applying Rust in automotive. Next slide, please. On this phase, I would like to pass the stage to my colleague Serhii. Please go on, Serhii.
Hello, everyone. So now I'll give you a brief overview of two Intellias projects related to Rust and automotive domain. And here is the first one. So this is the project about Rust programming language incorporation to AUTOSAR Adaptive SDK. This has started about a year ago and still being developed by several members of AUTOSAR Working Group Safety, and Intellias is one of active contributors there. The main goal is adding Rust API on top of the existing C++ API. On this slide, you can see the architectural diagram of the project. At the bottom level, there is a POSIX-compatible operating system, on top of which there is adaptive AUTOSAR platform consisting of multiple services with standardized C++ API. For instance, log for login, or per for data persistency, and etc. There is a special called COM, or communication. It's not used directly, but rather via skeletons and proxies. The glue code generated from the service definitions you heard before. This is the base for C++ AUTOSAR applications like the one at the left. And there goes our integration. So we have developed wrapper C API and Rust API on top of it. And this API helps building native Rust AUTOSAR application. Now this API is in development, so it's still not complete. This is the communication diagram. As you may notice, some additional layers were added for Rust applications to communicate with each other and other C++ applications. The main idea is communication transparency. All the applications can talk to Rust applications the same way as they talk to C++ applications. Now we'll go through the key points of the implementations. So we'll just talk about 3 of them, but there are many more. So firstly, we are using async Rust a lot because our SDK has a synchronous API based on futures, so we are resembling it. And the runtime we are using now is small, but there are plans to replace it with async runtime with other async runtimes. The second big thing is code generation, which consists of 3 parts: C++ bindings generation by the existing tooling, Rust bindings generation from service definitions, and these bindings are packed into a Rust library. And the third thing is C bindings derived from the generated Rust code with C bindgen, and so that the app code could be called back from the C++ layer. And finally, we are first compiling the project to different platforms supported by the SDK, which creates some challenges for us because the linkers are different from the standard one, which is LLD for Rust. And now here's a small example of the main functions of C++ and Rust AUTOSAR applications respectively. Basically, it's the same application. And here you may notice that the Rust code is much more concise and is using some async calls there. So now I will give you a brief example of how the code generation is going on. So there is an AUTOSAR service definition. It's basically an XML document. And here you can see the definition of a method called adjust with two input and with one input and two output parameters. And from this definition, our SDK would generate C++ code. And our Rust integration in turn would generate Rust proxy or the C wrapper of this method, calling it asynchronously. And at the bottom, there is an example of how this could be called from Rust application. It looks much simpler than the rest because all the complexity is hidden inside the integration layer we're working on. Next chapter is about a practical example of an application based on this Rust integration concept that we have just seen. So Intellias has recently initiated an internal proof of concept project of Rust AUTOSAR integration. It's a wheeled robot capable of autonomous parking with software written in Rust and running on AUTOSAR adaptive demonstrator platform, which is the reference platform we're working with. And the goal is to gain some experience in real automotive Rust projects and to extend the company's portfolio. Now I'll briefly explain the main algorithm. So the robot is driving past some wall with parking slots and scanning it with a side-attached ultrasonic sensor. Once a big enough slot is found, it performs a parallel parking maneuver, occupying the slot. And the calculation is based on pre-spaced polyline estimation for the parking lot. Also, the autonomous driving is supported by odometry, which is the estimated vehicle position based on counting wheel revolutions. So this is how the maneuver looks like. So now the project hardware setup is like this. The project is controlled by a Raspberry Pi connected to the host computer with Wi-Fi. And there is the adaptive platform installed on it. In the robot, we also have an ultrasonic distance sensor, a motor driver controlling motors, and speed encoders. And now here's the software design of the project. We have a hardware abstraction layer over sensors. Currently, it's just one sensor, ultrasonic distance sensor. And it's linked to a data processing algorithm layer, which is not yet implemented. It's supposed to pre-process all the data. The communication with the host is based on RRCOM, which is AUTOSAR communication subsystem. All of this is packed into a Rust application running on the AUTOSAR adaptive platform as a service. And also there is a GUI client application which visualizes the free space data and the vehicle position. And now I'll show you a brief demo how it looks like at the moment. So currently it's rather primitive. There is no robot platform available yet. So forward movement is simulated in software. We're using a box that serves as an obstacle, moving it to and from the sensor to generate some free space data. And you can see clusters of dots which represent the free space polyline. And there's a lot of noise now, but it will be ruled out once we implement the post-processing algorithm. So now what are our further plans? In the Rust integration project, we are going to replace the C++ COM stack with the Rust on-wire protocols implementations like Summer, for example. And this is done to reduce the complexity of code, which is quite complex now because of different layers and FFI and so on. Also, we are going to integrate the project with AUTOSAR adaptive demonstrator platform. And next thing is to extend the Rust integration to AUTOSAR classic platform. And it should bring some great benefits because Rust has built-in support of embedded development, like barebone, and with no STD configuration. And on top of that, there is a great async framework called Embassy. And as for our robot project, next steps would be adding the data preprocessing, replacing the movement simulation with the real robot chassis, and implementing all the vehicle parking algorithms. So what conclusions could we draw from this? First of all, there is an active trend towards Rust incorporation into automotive. Rust provides memory and thread safety out of the box, which is of great importance to automotive world. And AUTOSAR is one of the technologies that could enable Rust for many car companies in the world. Okay. Here is a collection of links which could be of your interest. And a separate slide is about links that were that are about the timeline that we have shown before. Thank you. Now we'll talk about questions. Yeah.
Thank you so much, both of you. First of all, we have a poll, right, about the future of Rust development in automotive, right? You can vote. What do you think on this, and we can talk some more. Andrii has been answering questions that people were posting in the QA, which was honestly somewhat futile, because we're gonna ask those questions and answer them again because we want them to be part of the video anyway. So let's see. And we can go in any order, right? So people were asking about like other applications of Rust, not only cars, but like food, medical supplies, delivery robots, things like that, right? And Andrii?
Yeah. Basically, I'm not sure about other domains, because today we were talking more about Rust and AUTOSAR, and AUTOSAR is purely automotive technology. So it is used only in automotive, it's not used in any other domain. So for me, it's hard to answer about any other domains which also use safety critical functionality.
Yeah, I could tell from our side, like from Ferrocene's side, when we were discussing about like use of Rust in these safety critical scenarios, turns out like different industries have different set of standards. Automotive industry was relatively easy to start because though the standards are very, very hard to follow, but all standards are hard to follow, all right? For car market in particular, there is this one big group, one big industry association that that allows once we pass those standards and once we integrate with this stack, we'll be able to enable Rust usage across wide set of industry, right? And then moving from that to other domains like aerospace, for example, is much easier after you're done with cars. If you start with aerospace, then it's much more difficult. And meanwhile, people could already benefit from Rust usage in that industry. So car, relatively easy to start, relatively easy to get things standardized. And that was the goal. Right, the next one is, so AUTOSAR is mostly C and C++. So what's the point of using Rust?
Serhii, do you want to answer this question? I guess this one better suits to you.
Of course. The main goal is to make the development safer, because there are multiple studies that show that although there are different tools like static analyzers, different compilers, certified compilers, there are still a lot of human factor when working with C and C++, where there is no guarantee that you can do something wrong, and compiler is not obliged to control this. So in Rust, it's back into the language. So I have a borrow checker and exceptional design of the language, which enables us to write safe application out of the box, and it's very important for a big amount of applications which are functional safety critical. That means that they are somehow related to hazard exposures. Means that they could the failure in them could bring some harm to people in the car, and yeah, so it's very important for them to be safe, to be reliable and safe. And yeah, Rust could make it easier to write such applications. Also, it's more modern than C++ and doesn't bring a lot of baggage of backward compatibility. So it's yeah, it's has a lot of benefits apart from memory safety. So a lot of companies are trying to or are going to use it, but there are some things that currently are not yet available, like for example AUTOSAR integration that we are working on, and so that things are still being in some transition stage. Yeah,
I can bring one example. It's a pretty popular in automotive example. We'll not go into details, but anyway, I don't know, maybe 10 about years so about that, there was a case in Toyota when there was a bug in memory management, and they just at some point those code inside of the car go and corrupt a part of memory. It was a bad control of stack, and they just corrupt part of memory in other region, and car start accelerate, and that's all. And that basically this car start accelerating. Driver cannot do anything because it was because of this bug accelerating, and this car was fall into the wall and killed 3 people inside of this car. And basically it was even luck that no one of pedestrians was not there. Yeah, so there could be even more injuries. And that one case how bad memory management can lead us to very big harm. And in Rust, it is much more harder to make such kind of mistakes. in C++, we are applying a lot of static code analysis to avoid these cases. But anyway, you need to think about all mistakes you need to cover by this static code analysis. And like Serhii told, it's human factor. You just cannot cover all and miss one small point. Do not cover it by static code analysis. People also can miss something, and you will correct memory, and it will make not correct functionality. And especially now we are in front of autonomous driving era, yeah. And it's even more significant thing, because you let it go to the car, so driver not even controlling so much like it was previously, and there is much more software, and it is much more complicated to control of the software and so on. That is reasons why we are looking for more safe and reliable solutions for safety critical functionality in the car.
Yeah. There were other stories like this with other manufacturers. We shouldn't single out just one of them. And thankfully, these stories are rare and far between. And over time, with the adoption of Rust, they should be even less prominent than they are now. All right. People ask, like, are there any production cars right now that run some Rust?
No, not yet.
Yeah. So the short answer
I
is
would
not
say
yet.
probably, because not all software requires such.
Yeah, that was I was trying to get to, right? Your entertainment system thing that, for example, a car can show you the current weather, and it might be using curl to get to make or leap curl to make the request for that. And leap curl, depending on how you build and compile, comes with Rust backend for some or for some parts of AGP stack, for TLS and for the other things. So, and a lot of projects that currently run on top of Linux, like for some auxiliary stuff, like, I don't know, sound system or whatever, they now start to add modules written in Rust. So you might have a situation where one of the few million lines of code that every car has currently, right? One of them will be running Rust. But inside the, what's this called, ECU, the electric control unit, right now there are no Rust code. Right.
Also, it depends. So if it's some HMI application, it's human control interface.
Human machine interface.
Human machine interface. So it's not covered even by ACL level, so it can use Rust. Also, they are bringing Android Auto and Kotlin there, so they are also not part of this. So you can see that not only Rust is trying to have some share there. And yeah, in this area, there can already be some Rust applications. I can tell about BMW. They were using some small system parts that were written in Rust, but it's not. It's more like system level software, and it's not covered by ACL levels. There are already some attempts to use Rust, but it's going to be better.
Cool. So we have a few more questions, like people asking, are operating systems like AeroOS, which is robotic OS, or Aeros 2 are using? And Andrii mentioned that AUTOSAR is already a platform. You build stuff on top of it.
So I can extend it a bit. So basically, it is possible to use both of them inside of the car. I didn't hear about such examples, but it is possible. So you can deploy AUTOSAR Classic on one ECU, AUTOSAR Adaptive on another ECU, and for example, ROS on third ECU. if you want, if it makes sense. But our projects, which we were talking about today, they are about Rust integration into AUTOSAR. And if you use AUTOSAR, you cannot use anything else.
Mhm.
I can add about ROS. So I've worked with ROS in one of previous projects, and they are mostly used to do some R&D. So they are not used in real production. They are used to develop some algorithms like autonomous driving, and then they are written in different platforms that are more native to a certain car maker. So that's the thing that I know, but maybe there are cases when it's used in real car, but I doubt it.
Yeah, probably yes, because as we told, Automotive cares a lot about safety, and we have a lot of things which we need to do to prove the safety of this technology. And for us, it's not compliant with automotive safety standards. And of course, it will be hard to release this car on needed safety level. So maybe for some not safety critical, you can use it, but still, it will be hard to use for any safety critical things.
We have quite a few more questions actually. So do you have time to stay around for longer?
Yeah, I have a bit of time.
That's cool. That's cool. So people ask, like, while you were integrating with Rust, have you found any bugs in the underlying C++ layer?
Well,
Nope.
well,
yeah, I was wondering,
the question was about the applications, but we are not working with real applications. We are working with the standard. And oh, sorry.
Yep.
So the idea is that we are working with this AUTOSAR adaptive demonstrator platform, which is the reference. It's not used in any car. It's used to build other platforms which are certified, and they are closed sourced. And we are using so-called sample applications, which are demonstrating the abilities of this system. Yes, there are some bugs there, but I wouldn't say it's the software is highly covered by tests or something.
Yeah. Oh, all right. Okay. I'll mark this as answered. Yeah. Skip this. Do you see at the moment some Rust applications in the standard software, the big automotive company like Toyota, Volkswagen Group, GM, Tesla, etc., like not in the control unit, but in the entertainment system and other parts? There's definitely, at this point, there's definitely some Rust in there already, because they do this over-the-air updates. Right, and a lot of these cars for entertainment systems, they're running Android, and Android has Rust inside. So, yeah. Have you measured the amount of unsafe code you had to write? Do you use any unsafe logs to talk to C? I presume yes, but
of course,
was it a was it a big part of work, or was it a relatively small part of work?
I would say it's the biggest part, because of the I think Rust that we are trying to implement there is a lot of things that we need to do, and it's not like C API, it's C++ API with objects, so we need to maintain some binary compatibility. There is a lot of bugs there. I guess when we're talking about safety of the application written in Rust in such a manner, so the main source of bugs would be in this integration layer.
Yeah. I was wondering how you do that, right? Do you Did you write your bindings using like cbinding manually? Did you use some cxx.rs or any other like builder to make Rust and C talk to each other?
Okay, I can cover that. Yeah, we were thinking of using CXX, but there is a lot of complications when using it because part of the code is generated, so it's not possible to include it at the time when it's when the Rust code is written. So it's all generated. We use cbinding to generate C bindings for C++ code because it's two-way communication, and basically objects are passing the FFI layer to and from. So, for example, there is an async call, and you need to start it in Rust and then carry it on in the C++. And then return the result in the Rust. So it's rather complicated. Yeah, we have already fixed some bugs there. Yeah, related to lifetimes. Yeah, lifetimes are also very complicated, and also we're trying not to use nightly Rust because we're not using it. Some things are not just possible. So we are also thinking of using implementing the synchronous API on top of our, just to simplify things, because yeah, we are waiting for async traits to be part of
part of the standard.
Stable Rust, because without them, it's not so good. But as I said, it's still in progress, and some things are changing. So current state is not how it would look like in a year.
Yeah. I want to interrupt us because I want to mention to participants that the next room is opened. So if you want to go listen to the next talk, you can close this window, go back to the lobby, to the website, pick the next room and join there. But I presume those that stay with us are still interested in this topic more. So let's continue discussing it here. So we do have a single track conference, but it works like if you're here, then that means you are in a corridor and someone is already started the next talk. So anyway, I wanted about async traits. I can tell you that it's a big can of worms. I'm not really participating actively in async working group, but I'm one of the people who are like reviewing its work all the time at Faros. And it turns out making async traits is like several layers of complexity, and I was expecting them in Q1 this year based on what I saw in the progress in the middle of last year. Right now, it doesn't seem like they will come until Q3 or Q4. So, and if they come, they will probably come in some limited state, and that makes async work a bit complicated because you have to target specific runtime on one side and also write in individual futures on the other side. I assume since you were using small, you had to implement small futures, small aware futures for AUTOSAR, right? For Aracom, right?
Yes. Well, there is a lot of code. I can't quite remember this.
Yeah, we will not go there. We will not go into details. It's just very, very cool to see that not only you did just basic integration, you also decided to tackle on the async question, which is a very, very complicated subject on itself. Right. So people like a more general question, right? We talked about like Rust coming up to cars, etc. Like there is a other side of the coin, right? for Rust software to appear in the car, someone has to write this software. And do you feel like there's going to be a big uptake in Rust projects at companies that participate in automotive industry at this point?
So basically, I can take it. For now, we see some small activities about it. We also at Intellias were looking for some Rust developers, and it's not easy to find, to be honest, because for automotive customers want to have automotive experience, and it's chicken egg question what to start first. Candidate should know Rust and automotive, but there are no projects already with Rust and automotive, not much of them. But I know that Rust is used actively on Volvo, for example. They have projects. I know that the BMW had some projects. I heard about projects in Daimler related. So a lot of companies are exploring projects with Rust, and when we will prove from our side that it can be used for AUTOSAR adaptive. For example, when some companies will finish those projects which may be not announced now but in progress, and show also prove that it is working Rust with automotive world, then we will probably have this pump. Of course, I don't know how long it will be, because it can be something more like hype, but anyway, we will I expect this pump, that we will have it at some point, and I feel that this point is pretty close.
I would add that the project do not have to start in the car at the car manufacturer side only. Like companies like Intellias are doing some experimentation. Companies like ThoughtWorks, also another software consulting company, is doing a big push. And on their side, the story goes similarly, like Andrii said. They have a bunch of people who worked at automotive industry on software side, and now they have teach them Rust or switch them to Rust. But also some people who know Rust might come in and join later, because this is something we observed in many industries. The industry starts moving from C++ to Rust, and move developers from C++ to Rust. And then they realize that they need pure Rust experience, and only then they will add people who are more like Rust, have general Rust knowledge, but not the domain knowledge. Domain knowledge usually comes first in these industries, and car industry is one of them. All right. Okay, this was answered. Let's see what we have. Oh, that's an interesting question. If we have two systems that have different safety level requirements, does it mean that they do not share memory? They have their own memory hardware separately?
Yeah, I think so. It's not possible.
Mm-hmm.
Or at least to violate the higher requirements. If there is ACLD and ACLC, so it will violate ACLD if they share memory, I guess.
Yeah, so basically, general approach is that lowest ACL level is your ACL level. If you want to put components, for example, ACL B, and then you will put component with ACL A at the same hardware, and will communicate with it. You can put it on the same hardware and check that it will not corrupt memory. It's possible also. It's not mandatory that you will not put it, but it's hard, and in most cases, it's these components are just split to different hardware, and it really reduce amount of work It's much more easier just to split them to different hardware.
Yeah. All right. So people ask general questions about AUTOSAR, like, is it only about autonomous driving, or there are some other features that it covers currently? What does AUTOSAR
It's
do?
totally not about autonomous driving. You know, AUTOSAR, especially AUTOSAR Classic, it's very old, well-known technology on the market, and main for it is to work with embedded features inside of automotive. So you can work with some stabilization systems and so on, which are ADAS systems are on the market from early from the beginning of current century, let's call it like that. Yeah, so autonomous driving is new challenge, and basically it's hard to apply even autonomous driving system on AUTOSAR Classic because it's optimized for this embedded things and low latency operations, and mostly for autonomous driving, and not only for over-the-air updates, for connected cars, technologies, and so on, was created AUTOSAR Adaptive, and now we are working with it. We'll see how good it will meet these challenges. So yeah, but in general, AUTOSAR, it's for embedded software of the car. It's not about autonomous driving, and autonomous driving, it's something pretty much new, which we are working with now.
Yeah. And when we talk about autonomous driving, it doesn't mean like full scale, like you sit in a car like a passenger, right? A lot of subsystems of autonomous driving can be applied in some smaller cases, just making sure a car doesn't like bump into other cars, or parking assist technology, things like that, right? So a lot of these new things, while new, we don't have to wait for the full self-driving cars for it to be usable. So a lot of this might trickle down into AUTOSAR, not AUTOSAR itself, but software built on top of it.
Yeah, by the way, can do one comment here. Unfortunately, I have to cut out this slide about levels of autonomous driving because of time limits, but I had it. So if people are interested, they can Google this, call it the Serhii levels of autonomous driving, and we have 5 levels. Let's go even 6, because we start from 0, no automation, and now we are about on the 3rd level, starting 3rd level of this autonomous driving scale, and would be more correct even to not call autonomous driving and call highly automated driving, because we are not talking about autonomous driving now. We are talking about highly automated driving, and even here we are not in very mature state. So
so you used a reference platform for to do a technology demonstrator. Do you think that part of this, or part of the SDK in general, will be available for us developers in future, for everybody who wants to do something with AUTOSAR?
I cannot predict the future, so there are plans to include it to this demonstrator platform. Currently, it's a side project. It's not included. Then we are going to include it to the standard, or at least not include or include it to the demonstrator, and it would be like an alternative API. So there's currently some bureaucracy in the consortium, so they are not willing to accept Rust as a full software stack language. That means that you don't want to write the whole stack in Rust. But yeah, there is some pressure from some members of the consortium, but the management is not currently open to this. So most probably it will be like a wrapper API over this C++ standard API, and it will be available. Well, the whole demonstrator platform is not open source, unfortunately. It's also a big question that has been discussed for quite a long time. There are some licensing issues which don't allow it to be open. And yeah, there are legal matters. And so, but for the members of the consortium, it would be available in the nearest future, maybe next year. That's my prediction. I don't know.
Yeah,
sure.
That's cool. We like on our side, I think FileSync compiler should be somewhat available, also not open source, but I don't know, to individual partners first, and it will also be available only like the plan I think was to get it done last year, but some certification takes a long time, so maybe this year we will have something. People ask, like, if you use unsafe code, right, what's the point of using Rust then? That's a general question, not related to cars.
Well, unsafe code doesn't mean it is broken. It only means that you need to take it with greater care than other parts of code. So you cannot write currently without unsafe code. So our aim is to do all the programming in unsafe inside the wrapper level and show only safe API, which don't need to make you use these unsafe parts. Well, the only way to make it not use unsafe is to write it from the bottom in Rust, which is not possible. Well, at least 100% possible. Maybe it could be somewhat reduced. I mentioned that we are trying to or we are planning to replace some parts like communication stack to Rust implementation. And after we do it, we will remove a lot of unsafe code already.
And one comment from functional safety perspective, basically, as Serhii told, unsafe, doesn't mean that it is broken code. You just need to make more care about it. And if we will put this unsafe parts into wrapper, which maybe even will be generated by scripts, and application developers will not have to do it, then we can do, from functional safety perspective, justification. You can just write your justification as developer of this code that yes, you have checked it, and you make sure that it is safe and no problem with functional safety on some level. Yeah, of course, we have AC levels, and that can work. This approach is working on production projects. It's not a problem. It's not common approach, but anyway, sometimes you have some library which is not certified for needed AC level, but you check, test, go inside, analyze it, and know that you can use it, this part of this library, and it will not broke overall safety. You can just write this justification, and your overall safety chain will be correct. No problems also with this.
Yep. The way I see it, right, you have to be careful inside unsafe blocks in Rust. If you write C++, all your code is inside a big unsafe block, so you have to be careful all the time. So that's one of the biggest reasons why Rust is so interesting. Final question is, like, do you hire Rust developers at the moment?
Not at the moment. You know, we were looking for. I even told about it before that at some point we were looking for a Rust developer for automotive project, but it was not so easy to find. To be honest, customers have very high expectations for such developers, and currently we are more working with this concept and preparing ground for this more intensive growth of Rust projects in automotive and AUTOSAR especially, and then hopefully projects will start, because Intellias is an outsourced company. We are not product company, so it's hard for us to start some project by our own. We're more working with OEM and tier 1 companies projects, but we are preparing this basement and preparing. That is also one of the reasons why we really want to join this conference, to show developers these perspectives, and to show to make marker that guys, please, let's start prepare for it. We are working to enable this project, and we are expecting that you also will be ready with some background and level of understanding of automotive to join these projects.
Thank you so much. At the end, I want to mention that our poll about the future of Rust showed that 43%, almost half of participants, expect a lot of projects in the next 3-5 years around automotive for Rust. And I agree with that. And another 36% thinks that there's going to be some activity, but it's hard to predict it for now. Yeah. Personally, I have somewhat an insider perspective as well, because I work at another another consulting company that also does some work for automotive. A lot of things that are happening right now is the groundwork, and the real work, like building exact software that is going to target specific car models that are going to be released in the next few years. This work has not started yet, but it may start very, very soon. Either this year, next year, the year after, which in car industry is incredibly quickly, right? So we are optimistic about it. Thank you so much for coming. Thank you, Andrii and Serhii, for answering all sorts of questions. This is very, very impressive work that you are doing, and it's very, very cool to see this work being done in Ukraine, in our company, in the company that has a very, very big representation among Ukrainian developers. So we'll see. We're always interested in seeing more challenging, more important, more critical projects coming on, because we have such a good set of engineers with a very, very good skill set, curiosity, and diligence, and we want to see more of that coming in. So thank you so much for doing all that once again, and thank you all for staying around, for us asking questions. And if you want to know more, we'll have links, we'll have the presentation, we'll have videos released at some point. I don't know exactly, but it's going to be like in a few days, in a few weeks, I don't remember. So we'll figure it out. But follow the news on Telegram, on Twitter, and other places. Thank you so much for coming.
Thank you all. Nice to hear you.
Yeah, thanks for your attention.
Yeah.
Bye.
Great. Bye.
Bye.